like to welcome you all to the second installment of our look at function generators and waveform generators. If you remember what we did last week, we looked at the function generator. Actually, we looked at three different function generators. We compared them to each other. And what we looked at were, for instance, the type of different functions the function generators were capable of producing. So we looked at square wave, triangle waves, and sine waves. And we also changed the parameters on them. So we changed the amplitude, we changed the frequency, and so forth. This week what we're going to do is we're actually going to exclusively be focusing on the Siglent 1032X function generator, waveform generator that's behind me here. And the reason why we're going to be focusing exclusively on this is because what we're going to be looking at, the other function generators could not actually produce. Okay, so after the break we're going to come back and we're going to look at those different things that we can do with this waveform generator behind of me. So come back right after the break. So if you remember from last week when we talked about the function generator, we said that the function generator is capable of producing three types of main waves, and those were a sine wave, square wave, and a triangle, sometimes called a ramp. However, when it comes to arbitrary waveform generators are capable of producing any electrical waveform that may be used for example, communication systems, or any other system that, let's say, you may have or may want to have under test. There are some common ones that most waveform generators can produce, and those common ones can be put into three main categories. Those three main categories are: you can, for instance, make modulation type schemes within or from your waveform generator, arbitrary waveform generator. You can also do frequency sweeps, and you may do burst type signals. Now, the type of waveform generator that we will be using is, again, my SDG 1032X Siglent waveform generator. And for this waveform generator, you'll notice that the three main categories of waveforms that we talked about are actually on the front. So the first one right here is for modulation schemes. The second one here are for doing frequency sweeps. And the third is for doing burst type signals. Let's go ahead and take a look at those modulation schemes. Before we get there, again, remember that we're going to be using that first button there on my Siglent SDG 1032X in order to produce the modulation schemes. The first waveform we're going to look at here is the AM modulated waveform. And so what I'm going to do is let's just go ahead and zoom in a little bit so that we can focus a little bit more on the screen here. So for this waveform generator, in order to go to AM, we go over here and click the type that we need, but it's already on AM. And you'll notice on the screen there's a number of different options. So we can pick the AM depth, which I'm assuming is the modulation index. We can also pick the AM frequency, and so this is the intelligence frequency. And then of course we have the carrier frequency that's over here. And the way that we know that this is a carrier frequency, by the way, is because this frequency is actually higher than this frequency, so this one has to be the carrier. And for our AM waveform, we're going to have a voltage peak to peak of 4. Let's go ahead and leave that as a 0 offset with a 0 phase. And so we can actually use this and actually produce an AM waveform that we can send to our oscilloscope. So I'm going to go ahead now and I'm going to turn on my channel 1. And by the way, channel 1 here is being fed into my oscilloscope's channel 1. And so now that it's set and we go up here to our screen for the oscilloscope, you'll notice that there is an AM waveform on our screen here. And by the way, again, remember AM stands for amplitude modulation. Okay, now so this actual waveform generator can also produce an FM frequency, And so in order to change it to FM frequency, we got to tell it the type of modulation that we want. So you'll notice that it's AM currently. We can change it to FM, and on here it shows, well, it doesn't quite say that it's FM, but and when I say that, I mean the waveform that's in here. That doesn't quite indicate that it's FM. Remember, FM stands for frequency modulation. So what that means is the frequency at some points are going to be fast, the frequency at some points are going to be slow, or it's going to change rapidly at one point and not change as rapidly at another point. We have an FM deviation of 100 hertz, and we have an FM frequency of 100 hertz, and we have our carrier up here of 1 kilohertz. And so if we look at what this looks like on our oscilloscope, you'll notice that if we look at the signal on here, there's different points where the frequency are actually higher, so in here and in here, and then there's points where the frequency is actually lower. Okay. All right, so that's FM frequency modulated signal. Now the signal generator can actually, or waveform generator, can actually produce a number of different waves, which again makes this stuff really, really cool. And so if we look on here, we'll notice that we have the option of doing a phase modulation. Okay. And so phase modulation, by the way, is just another form of, or frequency modulation is actually a form of phase modulation. We also, and let's go back to AM. Let's go back to AM. So we can, if you notice here, what it's saying is the, what's called the intelligence signal here actually has, is set as a sine wave. We can actually change it to a square wave, and that's something I didn't mention before. And we can change it to any of these waveforms for any of the modulation schemes on here. So we have a square wave, and so now you notice the square wave there. And so we go up here to our oscilloscope, and you'll notice that we have our square wave being modulated, or pardon me, the carrier wave being modulated, and it shows square in that area right there. So again, this is some really cool stuff. Back in the day, if you wanted to do this sort of stuff, what you'd have to do is actually get two function generators, one generating a frequency higher than the other, of course. One frequency, the one that's higher, would be the carrier, and then you'd have to feed both of those signals in to a nonlinear device in order to actually do the modulation. But because of newer technology, digital technology, we don't have to actually do that sort of stuff. All right, so we're talking about some of the other waveforms that it can produce. So this kind of looks like a ASK, or amplitude shift key. And let's see if we go over here to the type of waveform and we change this to ASK. You'll notice again, it kind of looks like the one that we were looking at before with the square, but it kind of looks like an amplitude shift key. And if we go up here to the oscilloscope, this is the waveform that it generated. Let's go back down here. Again, really, really cool. Let's change the type, and instead of ASK, which is amplitude shift keying again, let's go ahead and try FSK. And so if we look at FSK up on the oscilloscope, perhaps what we can do is just auto stop it at some point. But I'm not going to go through that on here. So that's, again, that's a FSK. Let's see what other types we have in here. We can go to our second menu, and on our second menu we can create a double sideband AM waveform. And let's go up here. And that's what that would look like on our oscilloscope. Come back down. We can also create a PSK, which is a frequency, pardon me, phase shift key on here. Okay. Man, I'm just excited about the different things that I can actually test with this.
and of course not having to, you know, go through and create a circuit that's going to mix the two signals together and then have two function generators that actually creating two different signals. You know, just having one and being able to do this is just, to me, it's just crazy. All right, so again, these are the different types of modulation schemes that we can create with this Siglent 1032, and we can change some of the parameters on it. I didn't change a carrier, by the way, but if we wanted to change a carrier, we'd actually just go over here to the parameters, and that will then give us the opportunity, and you'll see here, it'll give us the opportunity then to change a carrier information. But anyway, as I was saying, this is some of the cool modulation type waveforms that we can create with this Siglent 1032 waveform generator.
All right, so again, the second type of waveform that we're going to be looking at is the frequency sweeps. And so in order to produce frequency sweeps, we're going to use that second button there, right there, that we're looking at on the SDG 1032 Siglent waveform generator. So let's go ahead and take a look at the waveform generator actually producing frequency sweeps.
In order to do that with this Siglent waveform generator, what we would do here is go over and click on sweep. So we've done that. And then we have a couple of options that are in here in order to do our sweep. And I'm going to zoom in just a little bit. So we can tell the function generator over what period of time we want to sweep a specific set of frequencies, and we can tell what our beginning frequency is and what our end frequency is, or stop frequency. And so as you can see here, currently it says that it's going to sweep over a 1 second period, I guess is what that's saying. And it will start from 500 Hertz and go up to 1.5 kilohertz. Okay. And so if we now send that to our oscilloscope, you're going to notice that the oscilloscope, the frequency is actually changing. Now, I guess that's about a second. Looks like it's changing every second. If we wanted to change, let's say, the amount of time that it does that over. So right now it's on 1. What I'll do is, and I'll zoom out. I'll zoom out just a little bit here. So I can go ahead and change this knob here, and we'll change it to, let's change it to 5 seconds. All right. And so now that we've changed it to 5 seconds, we'll see here that the signal takes a lot longer, what I believe is hopefully about 5 seconds, to change from that 500 Hertz to the 1.5 kilohertz frequency. And let's say we wanted to go down here again, and instead of 1.5 kilohertz, let's go ahead and make this 2 kilohertz. So we would go ahead and let's see. So we want to change the stop frequency, so that's over here. So we get the stop frequency, and then what we can do is we can change that. Let's not do 500. Let's do, whoop, not 10K. All right, let's go to 500K. Oh, pardon me, that says 500 Hertz. Let's go to 2K. All right. So I've turned the knob till it got to 2K, and so if we go back up here over to our oscilloscope, you'll notice that the frequency now goes to what would probably be approximately 200K. Okay, again, this stuff is just, I mean, really cool, and I mean, it could be used for a number of circuits, but one in particular that we use this for, or we can use this for, is, let's say if we created a filtering circuit, whether it be low pass, high pass or band pass or stop band or whatever, and we can actually check to see as we're changing this, changing our frequency or sweeping our frequency, how the filter actually works, to see if, for instance, as it gets to a certain cutoff frequency, if it's at, you know, half power or whatever. Okay, so again, this again is pretty cool. Back in the day, if I wanted to do this, what I'd have to do is sit behind the function generator and turn it, but don't have to do that now. Just go ahead, set it up, and it would go ahead and just take care of that problem for me. There's a few other options on here that we can actually use. So instead of doing, let's say, a start and stop frequency, we can actually do a center frequency. And with the center frequency, we can pick what our frequency band is, or frequency span is what they call it here, or what would be the equivalent of bandwidth. We can pick that and we can put that in here. So there's again a number of different options. This stuff is again really cool. I love the fact that it does all this. You just gotta love modern technology.
The final mode or final type of waveform that we're actually going to look at is what's called burst signals. So we're going to have to set the waveform generator in the burst mode. In order to do that for the Siglent SDG 1032 Arbitrary Waveform Generator, we're going to need to press this button here in order to create our burst type signals. So let's go ahead and take a look at the type of burst type signals that the SDG 1032 waveform generator can produce.
All right, so the last thing we're going to look at on our waveform, or my waveform generator, and again, you can check to see if yours are actually, you know, if you have the options of doing these same things and try to, you know, find where they are on your waveform generator. But as I promised you all, as I'm working on this and learn how to use my own waveform generator, I'm just going to show you guys how it works. The last thing we're going to look at, there you go, last thing we're going to look at is, this week anyway, is for the burst here. And so burst type, for the lack of a better term, waveforms, we can use for, let's say, introducing some sort of a phenomena that occurs to our, you know, circuit under test to see if it's capable of, let's say, continuing to work after that phenomena, or if it's capable of working within the parameters that we wanted to during the phenomena. So an example of this would be, let's say, for instance, you know, the sun, every once in a while you have those solar flares, and solar flares actually interrupt or kind of screw up communication systems. And so we can use, for instance, this waveform generator to simulate the energy that the sun releases, that then gets to our communication systems and gets into it during times of like solar flare. And so in this case here, this week we can simulate, if you will, using the burst from the waveform generator and inject this into our, again, circuit on the test to see if, you know, how it would react if a burst of energy came into the system. And so currently it's set to burst, and you'll notice up here, this is what the burst signal will look like. You have, you know, these different points where it just, you know, give a burst, if you will, of energy, meaning it goes from something other than zero, or goes from something other than zero, okay, or ground. And so we can change things, different things on here. Like for instance, you notice that up there was one cycle. Okay, and you'll notice that it says one cycle here. So we can change the number of cycles. Okay, and I'm going to turn the knob. You don't need to see me doing this. But it says that, okay, it says that we have 3 cycles. So if we go up to our oscilloscope, there we go, we have 3 cycles. Okay, let's see, what else can we change here? We can change the burst period. So currently it's at 10 milliseconds. And so we can change the burst period. And so I moved it there. So let's go ahead and make this, let's make it something less than 10 seconds. So I made it 5 seconds there. Or is that 5 or is that 6? Yeah, that's 5. All right, so 5 seconds bursts, between bursts, and 5 milliseconds, pardon me, between bursts. And then we have 3 cycles in there. And so if I go up here, you'll notice that I got exactly that. And then over here, let's see, we can change the amplitude on the burst. So right now it's at 4 volts peak to peak. And so we can actually change that 4 volts peak to peak by doing similar to what we did for the amplitude modulation or frequency modulation. Don't remember which one it was. We go down here to parameters, and it would immediately take us over to the menu over here. And so then what we can do is say, okay, let's change it from 4 volts peak to peak. So instead of looking at the amplitude, pardon me, we can go to the amplitude over here. Let's zoom out just a little bit. All right, go to the amplitude over here and tell it to do something other than 4 volts peak to peak. So let's make it just 2 volts or 1 volt peak to peak. And so if we go back up here now to our oscilloscope, you'll notice that the amplitude has definitely changed on the burst. So again, we can use this to test to make sure our circuit, works when some sort of phenomena occurs. And again, an example of a phenomena in this case would be like solar flares. And if we are testing a communication system, you can inject this into the communication system to see how it would kind of work during those certain conditions. All right, so again, this stuff is really cool. It allows you to be able to put your circuit under a number of different tests. It's just awesome. And believe it or not, this isn't even the end. These are just pre-made stuff that, that we can use. There's also the arbitrary waveform part that we haven't even talked about yet. And so I think that's what I'm going to do next week. We're going to talk about the arbitrary waveform portion. So again, come back next week. Let's see what else this stuff can do. Man, I sure hope you're excited about this like I am. We'll check it out next week.